Okay, I think we're almost there. Okay, let's see. All right, we're in business. All right, so let me go back to. Okay, so we're at F. All right, so what say you is the answer for F?
1 times 10 to the 6th.
Very good. All right. What about the next one, G?
6.71 times 10 to the negative third.
Times 10 to the minus 3, indeed correct. And the last one here, the second G, which should be an F, which should be H.
(4.5 times 10 to the 0).
Exactly. Actually, it should be 4.50 times 10 to the 0.
Sorry.
Again, I'll explain why that is so later on, all right? Okay, very good. Now, if you understand what we just did, right, where we're converting from the standard notation to the scientific notation, that means you should be able to do the reverse. In other words, if you're given a scientific notation, you should be able to get converted back to the standard notation. So let me, is it okay for me to clear all this? Yep. Okay, so let me clear this now. And then let me scroll down. So now we're going to do the reverse. All right. Let me get back my writing implement here. Okay. So what would be the answer for? Let me get rid of this and realize that part. Okay. So what's the answer for the first one?
23,000.
23,000. Yes, that's correct. What about the next one?
.00176.
Okay, very good. What about the next one?
.601901.
Okay, so you're saying that there are 6 zeros first after the decimal point, which I think is correct. Yep. And then 1901. All right. Okay, what about the next one?
0.865.
I'm sorry?
0.865.
Okay. What about M, the next one? 9,110. What about the next one?
54.
I'm sorry?
54.
Okay, and again, I should put a 0 here. Again, I'll explain why that is so later on. Next one.
1.76.
1.76. All right, next one. Okay, so 4 zeros before the 7, 4. Okay, very good. And that's basically it, right? And that will become important later on when you're doing, you know, problem solving, calculations, and so on. You might be asked specifically to write your answers in scientific notation. And in some cases, this is simply more convenient for us to do so. All right. Okay. So let me clear this. Let me scroll down to the next question. Now, the next question has to do with the concept of significant figures. All right. And in the videos, I spent a lot of time basically going through the rules for determining the number of significant figures in a measured number, right? Significant figures are important because very often when you're doing calculations, you have to make sure that your answer is recorded to the correct level of precision and that is reflected in a number of significant figures, right? Because basically, and I won't go through all the details unless you have any questions about this, but basically, this is necessary because whenever you're taking any measurements using any instrumentation, there's always some degree of uncertainty associated with that measurement, right? So there's no such thing as an exact measurement, okay? At best, measurements are estimations, right? Now in science, and I'm quite sure it's true in other endeavors, we try to minimize the level of uncertainty, but you cannot eliminate it, all right? That is just something that's inherent in the practice of measuring anything, okay? So therefore, that's why we have to pay attention to the correct number of significant figures in a measured value. So usually, when we're talking about the number of sig figs, it's always associated with either a measured value or some calculations resulting from some measured value, right? Now, that's one type of number that you'll be dealing with in chemistry and in science, measured values or numbers arriving or arising from measured values. But you have another type of number that you'll be dealing with, and these numbers are called exact numbers, right? And exact numbers fall into two categories. You have those numbers which are exact, obtained by definition, such as, for example, 12 inches is equal to 1 foot, 3 feet is equal to 1 yard. All those numbers are exact because those numbers are as a result of defined relationships, all right? Then you have some other numbers which are exact because they are simply counting numbers. You're basically counting the number of items, right? So if you have, let's say, a class of 20 students, then that 20 is what we call a counting number. It is not obtained by measuring anything. You simply do a head count of the students, right? That number is an exact number, all right? The thing about exact numbers is that they have an infinite number of significant figures associated with them, all right? So that's one important difference that you need to recognize between exact numbers and measured numbers. Exact numbers have an infinite number of significant figures associated with them, while measured numbers have a finite number of significant figures associated with them. Now, just to refresh your memory, just in case you have forgotten what you have watched in the videos, I'm just going to quickly go through the rules for, let me skip this part here. Right, so let's say you're given a question, and let's say the question has some measured values in it. Based on the information provided, you can tell the number of significant figures. So I'm just going to quickly go through the rules so that we're all on the same page. So these are the rules for determining the significant figures in a measured value. First rule is very simple. All non-zero digits are significant, right? So all the digits from 1 through 9 are significant. So for example, if you're given this number, let's say this represents a measured value, you can say that there are 3 significant digits associated with that measurement, all right? Now, all the other rules after this have to deal with zeros in particular situations, right? So this one says, if you have a 0, and in fact, if you have more than 1 zeros sandwiched between non-zero digits, then those zeros are significant, right? So we already know based on the first rule that the 4 and the 1 are significant, but the 0 as well, in this case, is significant because the 0 is sitting between the 4 and the 1, right? So here we have 3 significant figures represented here, and I think I have another example which has 2 zeros, this example right here, right? The 2 zeros are sandwiched between the 6 on one side and the 3 on the other side, so therefore those zeros are significant as well. So therefore, in this case, the total number of significant figures will be 5. Here's another example, and you'll notice that in the examples I just showed you, there are decimal points in the value. It doesn't make a difference, right? It doesn't change that particular rule. So in this particular case, we have 3 significant figures. Okay, the next rule basically says that if you have zeros at the end of a number and there's a decimal point anywhere in that number, then those zeros are significant, right? So here's an example right here, right? You have 3 zeros at the end and you have a decimal point in that number. In this particular case, that means that the zeros are significant according to this rule, right? So therefore, the number of significant figures here represented would be 5 significant figures. Here's another rule, or another example, I should say. In this particular case, we have a 0, only 1 at the end of this number, and again, you have a decimal point present. And it doesn't matter where the decimal point is, right? As long as you have a decimal point in a number, any zeros at the end of that number will be significant. So in this case, we have 5 significant figures shown here in this number, all right? Okay, now the next rule deals with a situation where the zero is not significant, right? Now, this rule says a zero is not significant when it is before the first non-zero digit, all right? Here's an example. In this case here, we have only one non-zero digit and it's preceded by 3 zeros, right? So according to this rule, those zeros preceding the 6 would not be significant. So there's only one significant digit being represented here, all right? Here's another example. Now in this case here, we have 2 types of zeros, right? We have the sandwich zero and we have the zero that appears before the 7, which is the first non-zero digit, right? So therefore, the zero that appears first is not significant, but the zero that is sandwiched between the 2 non-zero digits is significant. So therefore, in this particular case, the number of significant digits here would be 3. All right. I think I have another example here. Oh, no, this is a different rule. I'm sorry. Okay, so this is a different rule. This deals with a situation, again, where the zero is not significant. But the reason why in this case is that there's no decimal point in this number. If you have zeros at the end of a number, but there's no decimal point in that number, then those zeros are not significant. So here's an example of that. 5,000, no decimal point anywhere indicated, right? So therefore, those zeros are not significant. So therefore, there's only one significant figure represented here. Excuse me. I think I have another example of this. Yes, again, no decimal point, and we have 1 0 at the end, so that 0 is not significant. So therefore, there's only 4 sig figs represented here in this number. Okay, so that's basically the rules for determining the number of significant figures in a given measured value. So let me get back to the assignment. Okay, so basically this question is asking, determine the number of significant figures in each of the following measured quantities. Okay, so based on the rules that we just covered, let's deal with the A part. So how many significant digits are being, let me turn on my pen here. How many significant digits are being represented in this measured value? 3, exactly. So 3 sig figs for that one. How many significant figures are being represented in the next one? Nope. 3. And the reason why, and this goes back to what I was mentioning before. Whenever you're looking at the number of significant figures in a measured value expressed in scientific notation, we pay attention only to the coefficient. All right, we pay attention only to the coefficient in order to determine the number of sig figs. So we don't even look at this. All right, so basically this will be 3 sig figs based on the rules that we just covered. All right, okay, what about C? 6, exactly, because you have a decimal point here. This 0 is significant. This is sandwich. That is significant. And this is significant for the same reason, right? So therefore, the total number of sig figs here would be 6. What about D? 4 sig figs. Did somebody say something out there in Zoom? I heard a
Yes,
thing.
I just said the number of sig figs for D.
I'm sorry?
I just said the number of sig figs for D.
Oh, okay, okay. All right. Okay, so that's it. So before we move on to the next question, I want to go back to something I skipped over. Now that we have discussed significant figures, let me clear this here. Let me do this. Let me scroll back up. Now, if you remember, I said, which one was it? For this one here, remember I said, let me turn on my pen again. Remember I said that the answer for this one was 1.0 times 10 to the minus 2, right? The reason why the 0 here is important is because based on the rules that we just covered, the number of sig figs here would be 2, right? Because we have a 0 here at the end and we have a decimal point, right? So that is 2 sig figs. Whenever you're converting from scientific notation to standard notation and vice versa, the number of sig figs must be maintained. Very important. So therefore, when you move the decimal point 2 places here to get 1.0, you have to indicate that this is still 2 sig figs. In other words, this 0 here must also be included in the number expressed in scientific notation. So whenever you're changing from scientific notation to standard or vice versa, the number of sig figs must be the same. All right. And I think we had a similar situation with this one. Well, this one is simply 4.50 times 10 to the 0. But there's another one. I think it was, where was it? Let me go back down, scroll down. Let me see. Okay, this one right here, right? I think I made mention of the fact that the answer here for this one is 5.4, 5.40. No, I'm sorry, 54.0, my bad. 54.0, that's the answer, right? Again, because you have 3 sig figs here, when you convert from scientific notation to standard notation, you need to indicate 3 sig figs, which means that you have to keep this 0 right here, right? So basically you have to maintain a number of sig figs, regardless of whether or not you're going from scientific to standard or vice versa, all right? So I just thought I should mention that. Okay, so let me scroll down. In fact, let me clear this first and then scroll down to number 3. Okay, so now that we have covered sig figs, then it's also very important for you to understand how to round off appropriately when you're doing calculations, right? And there are some rules concerning that. In fact, there are 2 rules, right? There's one rule which covers how to deal with sig figs when you're multiplying and or dividing. And then there's another rule which deals with how to round off when you're adding and or subtracting, right? So let me briefly describe those rules and then we look at how we apply that to this question. So let me bring up my writing pad here. And I'm just going to make up an example to illustrate how these rules work. Okay, so let me make sure. Okay, so let's say you're given 5.92 multiplied by, I don't know, 7.893 divided by 2.6, all right? I'm just making up something, all right? So let's say these are all measured numbers and you're to do the calculation and give the answer to the correct number of sig figs. So let me get my calculator here. So, and you can do this, of course, with me because, of course, I'm subject to error. So if I make a mistake, let me know, all right? So it's 5.92 multiplied by 7.893, and then I divide by 2.6, right? Now, what I got on my calculator, I'm going to write out every digit. I got 17.97175385. All right, that's the number I got when I did this, right? Now, the question now becomes, to what extent do you round off your final answer? Now, according to the rules, whenever you're multiplying and or dividing, this final answer here must be recorded or rounded off to the lowest number of significant figures of the numbers involved in the calculation here. So if you look at each of these numbers here, you'll see that this one is expressed to 3 sig figs. This one is expressed to 4 sig figs. And this one down here is expressed to 2 sig figs. All right? So what does that mean? That means that this answer here must be rounded off to 2 sig figs. All right? So what would be the answer in this case? If you're going to round this off to 2 sig figs, what would be the final answer?
Would it be 18?
18, exactly. And that would be the answer. And that's basically how you deal with multiplication and division, right? You always round off your answer according to the lowest, excuse me, the lowest number of sig figs involved in the calculation, all right? Now, when it comes to addition and subtraction, the rule is different. You have to round off your answer to the lowest number of decimal places. So again, I'm just going to make up an example here. Let's say you're given 2.93 plus 3.041 plus 9.8, all right? So when I do this on my calculator, 2.93 plus 3.041 plus 9.8. The answer I got, and I'm going to write out everything here. The answer I got is 15.771. All right. So the question now becomes, to what extent do you round that off? And the answer is, you round this off according to the lowest number of decimal places among the numbers here involved in the calculation. So if you look at this number here, you see that you have 2 decimal places. Here you have 3 decimal places. Here you have 1 decimal place. So what does that mean? What's the answer in this case? 15.8, exactly. All right. So just to recap, if you're adding and or subtracting, you round off your answer according to the lowest number of decimal places, right? If you're multiplying and or dividing, you're going to round off your answer to the lowest number of significant figures, all right? So again, this is something that you have to keep in mind in the future whenever you're doing any problems that we're going to do in chemistry, problem solving, a lot of calculations involved, and you have to keep these rules in mind, all right? Okay, any questions about this so far? Any questions? Any questions out there in Zoom? Any questions? No? Okay, one more thing I want to talk about before I move on to the next problem. Now, this has to deal with what if you have a combination of, let's say, addition and then multiplication, because the rules are different, right? So let's say you're doing a problem and in one stage you're doing multiplication and then you have to divide or you have to add that to something else, whatever, right? So in other words, different rules for the different operations will come into play. Okay, so let me do a no on this and let me create an example. So let's say you're given 2.796 plus 3.12, and then we divide all of that by 5.08. All right, so let's say this is what you need to work out, right? So according to the rules, what you need to do is work out this part first, right? Because the mathematical operation here is addition, and then whatever you get here, you're going to divide, right? Now remember, whenever you're adding or subtracting, you round off according to the lowest decimal places, right? Lowest number of decimal places. So what I'm going to do is put 2.796, and I'm going to add that to 3.12. So on my calculator display, I got 5.916 divided by 5.08. But because we have 2 decimal places here, and we have 3 decimal places here, that means I need to round this off to 2 decimal places, right? So when I round off this part to 2 decimal places, what will I get? 5.92, exactly. The next step is to do the second mathematical operation, which is dividing by 5.08, right? And according to the rules, when you're dividing and or multiplying, you're going to round off your answer according to the lowest number of significant figures, right? So in this case, we have to look at the number of sig figs involved. We have 3 here, and we have 3 here. So that means we have to round off the final answer to 3 sig figs. So let me do that now. So 5.92 divided by 5.08, and I'm just going to write down everything, 1.171259843. So that's what I got on my calculator display. So when I round this off to 3 sig figs, what will be the answer? 1.17. So that's basically how you deal with that sort of situation where you have different mathematical operations involved where the rules are different. You do each part first, then you round off according to the appropriate rule, and then you move on to the next stage and you round off accordingly until you get to your final answer. All right? Okay. Any questions about what I just discussed? Any questions? Any questions? Okay, so I'm going to go back to the questions here. Okay, so based on what we have just covered, how would you deal with 3A? My throat. it's a combination of addition and subtraction, right? So how would he deal with this? Tell you what, let me just do the calculations here and write down what I got on my display. So 1.25 plus 6.2, and then I'm going to minus 8.01, and then I'm going to add 0.899. Okay, so
You would
I'm sorry?
you would round off to the lowest decimal, right? Of the
Exactly. Hold on 1 minute. Let me just write down what I have in front of me here. So on my calculator, I got 0.339. All right. So as I don't know who said it, somebody from Zoom said it, you round off according to the lowest number of decimal places, right? So what's the lowest number of decimal places involved in the calculation here?
1, so it would be
6.2, which is 1
0.3.
decimal place, right? So that means the answer here, the final answer would be what? 0.3. And don't forget the units, meters. You need to include the units because we have units here. So the answer here would be 0.3. Oh, this looks ugly. 0.3 meters. Okay, very good. All right, so let's look at the B part. Now, if you notice, in the case of B, you have two different types of operations where the rules are different, right? So, how would you deal with this? Okay, so you add 23.5 to 10, so that would give 33.5, but you have to round off to 0 decimal places. So when you round off 33.5 to 0 decimal places, that's what? 34. So down here, you're going to have 34 mils, right? And then you do the division. So let me do that division on my calculator. 78.8680 divided by 34. And this is what I got on my calculator. 2.319647 Now the question now becomes, to what extent would you round this answer off to? 2 sig figs, because you have 2 sig figs here. You have, well, definitely more than 2 sig figs above. So that means you round the answer off to 2 sig figs. And this becomes 2.3. Now the units here, you have to pay attention to because you have grams in the denominator part of this fraction and you have milliliters below. So the units here would be grams over mils. So you need to include that as well in your answer. All right? Any questions? Any questions? Any questions out there in Zoom? Okay, I'll take your silence to mean no questions. All right. Okay, so let me clear this here. Let me scroll down. So this question says, round off the following to 3 significant figures. So they're specific in this case, 3 sig figs, right? So let's start off with the first one. What would be, let me turn on my pen again. I keep turning it off. Okay, so what would be the answer when you round off the first one to 3 significant figures? 135, and don't forget the unit meters, all right? What about this one? Nope. I know this one would trip up some of you. How would we express 80 grams to 3 significant figures?
Would you put a decimal point?
Okay, where would you put the decimal point?
Would it have to be 8.00?
Well, not correct. It would be 80.0, right? Because by putting a decimal point here, you're making this 0 significant, and then you put a 0 after the decimal point to give that a total of 3 significant figures. And don't forget to put the grams here as well. Okay, what about C? 1 what? No, not 126. Yes, ma'am. I'm sorry. You mean scientific notation? Well, that can work. So what will be the answer if you do it in scientific notation? I'm sorry? You said 126 times 10 to the first? Okay. Well, that is not exactly scientific notation, but it is correct. You can express it this way. Another way of expressing it would be 1260, right? Because what you can do is drop this 5 and then increase the 5 here by 1 unit to 6, right? But when you drop this 5 here, because it's to the left of the decimal point, you have to put a placeholder 0 here, all right? So this is correct as well. Now, if you want to do it in scientific notation, the answer would be 1.26 times 10 to the 3, all right, mil. So any one of these would be correct, would be the correct answer for C, all right? Any questions about that one? Any questions? Any questions? Okay, what about D? 1.2 times 10 to the minus 5 express the 3 significant figures. Anybody? Now remember what I said earlier. Whenever you're dealing with significant figures and scientific notation, we only pay attention to the coefficient. All right? So with that said, what do you think the answer is? (1.20) times 10 to the minus 5. And the units here in this case would be millimeters. All right? So that's basically how we do those. Any questions? Any questions about any of these? Any questions? Okay, let me clear this. And let me do this. And let me scroll down. Okay, conversions. Right, so I did spend some time describing how to convert from one unit to the next. And basically what it comes down to is eliminating somehow the unit that you're starting off with, and then you work towards the unit that you're trying to achieve, right? So let me just look at some simple, oh, you know what, let me get out of this here, I'm sorry. Let me go back to my writing pad here. Okay, so for example, let's say, and I'm going to start off with a simple and then move on to a more complex example. So let's say you're given 35 inches and you want to find out the equivalent value in centimeters, right? So basically what you're going to need in order to answer this question is that you need to find out the relationship between the inch unit and the centimeter unit. And it is for that reason I have made available to you guys the tables. Remember the tables I talked about when I was talking about the canvas and where things are located, right? So the tables will give you, of course, things like the periodic table and so on. But in addition, it gives you the mathematical relationship between units, such as the inch unit and the centimeter unit. If you look it up in those tables, you'll see that 1 inch is equal to 2.54 centimeters, right? So therefore, this is the relationship that we're going to use in order to figure out what the equivalent value of centimeters that would be, that 35 inches would be equal to, right? So how do we do this? Well, we start off with what we're given. We're given 35 inches. And then we multiply that number by what we call a conversion factor, right? Where we express this relationship as a fraction, where one of these numbers would be the numerator and the other number would be the denominator. So the question now becomes which is which? Which number goes up here and which number goes down here? And the answer is the one that would allow you to get rid of this unit or has the same unit as this would be down here as the denominator. So here I'm going to put 1 inch, all right? Above, I'm going to put 2.54 centimeters, right? So the inch unit will go. So whatever you get in the final answer would be expressed in centimeters, all right? So basically you have to just do your number crunching on your calculator. 35 times 2.54. So the answer I got here is 88.9 centimeters. However, what we learned earlier in terms of rounding off will come into play now, right? So in this case here, what we have here is a defined relationship. So this here is exact and therefore has an infinite number of sig figs, infinite number of sig figs. Whereas this number here is a measured number, and as you can see, it has 2 sig figs. So it means that this number here has to be rounded off to 2 sig figs, right? So when you round this off to 2 sig figs, what do you get? 89 centimeters, and that will be the final answer, right? So that's basically how you do a simple one-step conversion. Now, there are some instances where things are a bit more complicated because there's no obvious relationship that you'd find anyway, in any case, in the tables that I would have provided. So again, I'm just going to create another example here. Let me just clear this. So let's say you're given 35 centimeters, and let's say you want to find the equivalent value in yards, let's say, all right? So if you consult the table, you won't see a direct relationship between centimeters and yards. However, you will find that, as we said before, 1 inch is equal to 2.54 centimeters. And everybody knows that 12 inches is equal to 1 foot. And everybody also knows that 3 feet is equal to 1 yard, right? So basically, we can go from centimeters to inches, and then from inches to feet, and then from feet to yard, right? So based on this flow chart, or whatever you want to call it, based on this here, we can tell that we're going to need 1, 2, 3 conversion factors in order to convert from the centimeter value and end up to the yard value, all right? So we're going to start off with the 35 centimeters, and our first concern is to go from centimeters to inches, which we already did before. You know how to set it up by now, based on what we did in the previous example. You're going to have 2.54 centimeters down here and 1 inch above, right? So the centimeter units will go. The next step is go from inches to feet. You're going to have 12 inches here, down here, and 1 foot above, so that this unit will cancel out with this unit. So we have achieved the second step. And then now to get to the final step, we're going to go from feet to yard. We're going to use this relationship right here, where you're going to have 1 yard above and 3 feet below. And that's a setup. The feet units will cancel out here and here. So your final answer would be the yard, would be expressed in a yard unit. So let me do the number crunching here. 35 divided by 2.54, divided by 12, divided by 3. And according to my calculation, again, you have to round off to 2 sig figs. So according to my calculation, I got 0.38 yards. And that's basically how you would do that. All right. So in some cases, you may need more than 1 conversion factor. And let me also say that it is possible for 2 persons to do the same calculation using a different series of conversion factors, right? So one person could use different numbers based on values given in the tables, but you should still end up with the final answer being, in this case, 0.38 yards, all right? Okay, any questions about this? Any questions? Any questions? Yes, sir?
So I do have a question real quick. So for the final answer, you would round off to 2 significant figures. Why wouldn't because 3 feet is 1 significant figure, so why wouldn't it be 0.3 instead of 0.38?
Okay, very good question. And the answer is that each of these conversion factors, right, are basically defined values. Whoops, defined. Right? In other words, by definition, 1 inch is equal to 2.54 centimeters. By definition, 1 foot is equal to 12 inches. And by definition, 1 yard is equal to 3 feet. And remember, when it comes to defined numbers, they are exact, and therefore they have an infinite number of sig figs. Infinite number of sig figs. All right? So basically, the lowest number of sig figs involved in this operation would be 2 sig figs from the 35. And therefore, that's why we have to round off the final answer to 2 sig figs. All right?
Okay, yeah, that makes sense. Thank you.
Okay. Another thing I want to add. Whoa, okay. Another thing I want to add is that there are some instances where these conversion factors are not exact. All right? And let me just give you a little rule of thumb here. Is it okay for me to erase all this? Can I give it? Okay. I'm going to give you a little rule of thumb here to help you to make predictions as to what conversion factors are exact and what are not exact. If you're converting from, how should I put this now? Converting from a metric unit or metric unit, all right? Then all the conversion factors are exact, all right? So if you're going from, let's say, centimeters to meters or kilograms to grams, you know, whatever the conversion factor you use to achieve those conversions, they are exact, right? If you're converting from non-metric to non-metric, again, the conversion factors will be exact, right? So if you're going from inches to feet, or if you're going from pounds to ounces, then those conversion factors are exact. Now, here's where things are different. If you're converting from metric to non-metric, or vice versa, so let me just do that here, then the conversion factors are not exact, with one exception. And the exception is one I mentioned before, going from the inch unit to the centimeter unit. 1 inch is equal to 2.54 centimeters, right? This is exact right here. That relationship is exact, even though the units are not within the same system, right? But every other conversion where you're going from metric to non-metric, or vice versa. So let's say you're going from miles to kilometers, right? Whatever you're given in the tables, you have to take that into account in terms of the number of sig figs, because that relationship is not a defined one. Or if you're going from, let's say, kilograms to pounds, right? Kilogram is metric, pound is non-metric. So again, in that particular situation, you have to take into account the conversion factors. Okay, or the sig figs. Okay, so with that said, and in the time that we have left, let's look at this question. Convert the following quantities. So in this case, we're converting from seconds to days, right? So the first thing we need to figure out is the relationship between the second unit and the days unit, right? So we know that, everybody knows that there are 60 seconds equal to 1 minute, and there are 60 minutes in 1 hour, and there are 24 hours in 1 day, all right? So let me start off with, well, before I even do that, so basically, in order to solve this problem, we have to go from seconds to minutes to hours, and then to days, all right? So basically, we're gonna need three conversion factors, right? So I'm going to start off with the 565,900 seconds. And my question to you is, what would be the conversion factor that I would start off with here? In other words, what would go up top here as a numerator and what would go down here as a denominator? Yes, sir. 1 minute would go above, 60 seconds would go below. So that this unit will cancel out with the second unit here. Good. What's the next conversion factor? What would go up top here and what would go below here as a denominator? 1 hour above, 60 minutes below. Very good. So the 60 minutes or the minutes will cancel out here and here. And then we get to the final conversion factor to go from hours to day. So what would go up top here and what would go below here? 1 day, 24 hours. Very good. And that's it. Right? That's the setup. The hour unit will cancel out here and here. All right. So let's do the number crunching. 565,900 divided by 60, divided by 60, divided by 24. And we have to round this off to how many sig figs? 4 sig figs, right? So let me just write down what I got on my calculator display. I got 6.54976,8519 days. So if I were to round this off to 4 sig figs, then what would be the final answer?
$6.550.
Excuse me 1 minute, whoever is talking on Zoom. It would be 4 sig figs because of this right here. And there's no decimal point after the 0. So therefore, those zeros are not significant, right? Okay, so I don't know who it was. Somebody was giving the answer over in Zoom.
Is it 6.550?
Exactly. 6.550 days would be the final answer. All right. Any questions about this one? Any questions? Any questions? Okay, so let me see if you can do this on your own. The next one, B, without my help. Let's see. 17 years, we're going to convert that to minutes, right? So let's do like a flow chart, like what I did here. How would you, what strategy would you take in order to solve that? Yes, ma'am. I'm sorry? Okay. Well, let me put months here. And then what? Months going to what? Weeks, okay. Okay, all right. So that's one way of doing it. And this is totally fine, right? What I was thinking of, which, you know, I'm just going to show you here, and this is just to illustrate that there are more than one way usually to solve problems. I could go from years to days, right? Because there are 365 days in a year. And then I can go from days to hours and then hours to minutes, right? So, you know, whichever way you choose, you should still get pretty much the same result, right? But since you suggested your method, I'm just going to go. What's that? All right. You know, okay, let me do my way then. All right. So, okay, I was about to erase it, but let me not. Okay, so what's the next step? Start off with the 17 years, right? So what would be the conversion factor going from years to days? What would go up top and what would go below? $365 days above and 1 year below. Okay, very good. What's the next conversion factor? Going from days to hours. What goes up top and what goes below?
$24 hours over 1 day.
24 hours above, 1 day below. Very good. Oh, by the way, this will cancel out with that. That will cancel out with that. All right. Next step. Next conversion factor. Going from hours to minutes. 60 minutes above, 1 hour below, and that's it, right? This unit will cancel out with this. So now we do the calculation part of it. 17 multiplied by 365, multiplied by 24, multiplied by 60. And the answer I got, and I'm just going to write down everything, 8935200 minutes. But we need to round this off appropriately. So how do we round this off to the correct number of sig figs? Well, what would be the correct number of sig figs we need to round this off? 2, right? Because we have 2 sig figs here, and these here are all exact relationship. All right, so that means the answer is what? Final answer, that is. 900? We're rounding off to 2 sig figs. Okay. So, wait, what did you say before? I thought I heard you said 900. That would be it. Because you need to basically oh, okay. Well, maybe okay. I'm sorry, repeat that. No, that would be correct. Based on this here. Anybody else want to help her out? I'm sorry? Okay, so you're thinking of scientific notation. All right. 8.9 times 10 to the 1, 2, 3, 4, 5. Yes. Oh, okay. Oh, okay. So this is 8.9 times 10 to the 6 minutes. Or, well, that's, of course, you know, I would answer it this way, being more convenient, compact, all of that. But if you want to do it the standard way, it would be 8, 9, and then 5 zeros after 1, 2, 3, 4, 5. So that would be 890,000. No, I'm sorry. 8.9 billion, basically, or 8,900,000, and that would be the answer in minutes. All right, so that's basically how that is done. Okay, well, I don't think we have enough more time left in today's class. We have only 7 minutes. But if you understood what we have covered here, then you should be able to do the rest. Let me just clear. Is it okay for me to clear all this? Okay, let me clear this drawing here. And let me just scroll down. So the rest of this question here is all conversions. Some of them, you're going to need to consult the tables, right? So make sure you do that. And some more conversions here for number 6. And then number 7, 8, and 9. Well, I'm sorry. Number 8 and 7 have to do with density. We didn't get to that today, but I would expect you to be able to complete those questions. And number 9 is something dealing with gas mileage. So make sure you complete those. Now, I will collect these assignments. I would say turn them in by Thursday. Now you can drop them off in my mailbox upstairs for those of you who would more likely be around here on campus, or you can submit it via Skype. And I think I've talked about that already, but let me just say that if you're going to submit any assignment by Skype, make sure that you scan it and submit it as a PDF document. All right? Make sure it's done in your own handwriting, and make sure it is submitted as a PDF document. And I would suggest also that you write your name at the top of every page so that when I'm printing it, I won't lose any of your any page of your assignment. And I'll make sure it's organized and all that. All right. I'm trying to set the deadline date as Thursday on this thing, but it's not cooperating. Anyway, so the deadline is Thursday. All right. Make sure you turn it in. If before then you have any questions, feel free to call me. You can call me during my office hours on the phone or via Skype. Which reminds me, make sure that you have created your Skype account and send me your Skype contact request. So far, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I haven't checked recently, so if you sent it already, don't worry about it. I'll get your name down. Remember, there's a 10 percentage point bonus being added to your first test if you sign up on your Skype, or if you create your Skype account and you send me your Skype contact request. All right, so make sure you do that as soon as possible. All right, so if there are no more questions in the time that we have remaining, that's pretty much it, folks. So I'll see you guys next week, Tuesday, and hopefully my voice will recover fully by then. You too, take care.
Thank you.
Take care, folks, out there in Zoom.
You too. Thank you.
Thank you.
Yes, ma'am.
Thank you.
Oh, I have a question.
Wait, hold on 1 minute.
We can submit stuff on Canvas, right?
Yeah, you can.
Okay.
Right.
Skype and in person.
Oh, okay.
That's why I was gonna do it too. Okay, never mind.
I'm getting old, forgive me. Okay, somebody had a question out there in Zoom?
Yes.
Yes, ma'am.
When are our assignments going to be graded?
Well, the reason why I want to collect them on Thursday so that I can grade it over the weekend and get it back to you.
Okay.
So I would say that you should be able to get them back by the latest Monday next week.
Okie dokie.
I have a quick
Thank
question.
you.
So for the first assignment, I turned it in through the Dropbox on Canvas. Is that okay, or should I send that one?
Yeah, that is
through
fine. Yeah,
Skype
that
as
is
well?
fine.
Okay. Okay.
Mhm.
Thank you.
All right.
And
Yes, sir.
I have one. So I created a Skype account, but where do I send you my account?
Where do you send what?
So I created the account. How do I how do I connect with you on the Skype? Do I
Okay, so my Skype address, it's in the syllabus. It's pete.nicely.
Okay.
And then you should be able to, I think they give an option about sending something like a Skype contact request or a friend request or something like that. I'm not sure. I don't remember the terminology. And
Okay,
then once you, I'm sorry?
Okay, yes, sir. That works. I'll make sure to go on and find that.
Okay, good. So yeah, if you do that, I should get it.
Okay, awesome. Thank you, sir.
All right, no problem. Take care.
I also
Oh.
had just, sorry, I had two quick things. One, are you gonna post I know you're gonna post the assignment, but it's not up on Canvas yet, so I just want to make sure that
I thought I
Um,
posted it this morning. Hold on.
the only assignments I see are assignment number 1, and then there's an undated assignment that says evidence of understanding, but that has nothing attached to it.
Oh, no. That's not where you're gonna get it. I'm sorry. Okay.
Okay.
So if you look, can you see my screen still, right?
Yes.
Okay. To get the assignments, you go to file, you go to
Files.
you
I
go
forgot
here.
about files.
assignment, spring 22. And then you're gonna see.
I see it. Chapter 2.pdf. I see it. Okay, I forgot to go there. Okay, thank you.
All right, no problem.
And then last thing is I sent you a Skype friend request like a week ago. I just want to make sure you got that.
What's your name?
Joseph Tyndall or Joey Tyndall.
Hold on 1 minute. Oh, yeah, I got you.
Okay. I just want to make sure. Thank you.
Yeah, all right, no problem.
Okay, thank you. Have a good day.
Yeah, you too.
I'm about to ask you, where's the assignment 1? Because it was this night, but I found it right now. This is assignment 1, right? That do,
Oh, I haven't graded it yet.
yeah, but that's assignment 1 right there, right?
Yeah.
Okay, yeah, because I was looking at the assignments tab,
Mm-hmm.
and I was wondering, what was assignment 1? Because I didn't know where it was at,
Oh, okay,
but I just found it right now.
right. Okay,
Also, I have one question about routing.
oh, yeah. Mhm.
Because it's something that, because I took AP chemistry, right?
Okay.
So my teacher has like, I don't know, I guess he learned a different way of it. So let me get an example. Okay, let's say we have a,
We get the marker.
so let's say you have this one here, like 524.7. He would say like, yeah, it says like 5 or more raised to 4, like raise the number, like right here, 7 is greater than 4.
So where do you want to round up?
This number right
Okay,
here.
right.
So, they say 5 or more, you round up. But my teacher had a rule where its number was even.
Oh, yeah, I remember.
Yeah, he had that rule.
I've seen that in some textbooks. I'll be honest with you. That rule doesn't make sense to me. I never learned it that way.
Yeah, you gonna do it that way?
No.
Okay.
Yeah, I remember In fact, the first time I saw that in a textbook was probably when I just started teaching at a university in Maryland, and this was probably back in 2001. And I'm like, this makes absolutely no sense.
Yeah, my teacher, I forgot. I know he went to Miami, but I forgot what year. Probably like early 2000.
Yeah,
No, not even 2009.
yeah, and you know, I get the impression that that was sort of like a new way of doing things, but I mean, I kind of understand it, but it doesn't make sense to me. That's just,
Yeah, kind of really understood that. Like, why would it be just
Right.
number?
right. Yeah, it doesn't make sense to me.
Yeah, that doesn't make sense. I can kind of see it, but not. All right, thank you. Have a good day.
All right, no problem.
Next week.
Yep.
Sorry about last class. There's an accident when all that rain started coming down.
Oh, really?
And then by the